So now let's talk about a substitution nucleophilic unimolecular, which is known as SN1 reaction, where S indicates substitution, N indicates nucleophilic, and 1 indicates the order of the reaction. It is a first order reaction. Now let's see. We have alkyl halide. Now an alkyl halide is there, and we have polar protic solvent. So here we have polar protic solvent. So we use the polar protic solvent. What are the polar protic solvent? Where the electronegative element is directly attached with hydrogen, like here we have water as a polar protic solvent. So here if we consider it as a rate determining step. So here this is alkyl halide, and alkyl halide we know it has some polarity, like it has delta positive charge, it has delta negative charge, and we know that the very first step is RDS. Now what happens? Now we know we have a polar protic solvent. In polar protic solvent there is generally a tail of hydrogen positive and the center is generally delta negative. Okay, so we have both of the free charge, like delta positive and delta negative. So what happens when we put an alkyl halide in a polar protic solvent? So polar protic solvent, when we put in polar protic solvent, let's take an example. We have an alkyl halide here, and in the first step it has delta positive charge and delta negative charge. It has a partial distribution of charge, so it is surrounded by again water molecule. But after going through the first step, it breaks into R positive and Cl negative. When it breaks into R positive and Cl negative, so they are now they are separated into cation and anion. Why? Because we have a polar solvent, like we have polar protic solvent. So we have water here, OH and H. So the positive tail, the negative tail of that polar protic solvent will surround the positive charge. So here if we see again this positive charge is surrounded by the negative charge of oxygen. So that's, and the chlorine, the chlorine part is the negative part is surrounded by H, the positive tail of that polar protic solvent. So that's why in case of polar protic solvent it enhance the SN1 mechanism. Why in polar protic solvent, again if we see, we have both negative tail and positive free. But in case of polar protic solvent we generally see that it don't have a free positive tail. So we know the negative charge is not surrounded by that. So here it is surrounded by a positive charge. That's why we can get it separate. When we can get it separate, we know that now we have free carbocation. Whenever we have a free carbocation, that means there is a rearrangement possibility. We have seen previous cases that there is a rearrangement in free carbocation. Whenever we get a free carbocation in a solution, so there is a possible rearrangement. Now we have a water as a nucleophile over here. Now what happening? First step, the carbocation and carbon ion get separating. Now we have water molecule. Now water molecule is acting at the nucleophile, and here we have MTP subshell. So oxygen lone pair gonna donates here, and now when next case, now there will be oxygen positive and H. Now what happens in next case, when H2 again we have H2 gonna take this and the Cl negative, that carbocation and carbon ion gonna make a salt, and we know that we will get an alcohol. So this is again substitution. One nucleophile is substituting another nucleophile, but it is a unimolecular. Why it is a unimolecular? If we see the very first step, if we see this is the very first step, okay, this we consider as the first step. Now first step involves only one molecule. Okay, first step involves only one molecule. That's why it is considered a unimolecular reaction, because first step we consider it as an elementary step. Now only elementary step we have seen molecularity is 1, when in molecularity and order are same when it is an elementary. So here the order is also 1. So if we see the overall reaction, we consider it is a 3-step process. It is a 3-step reaction. So here reaction proceeding in 3 steps. This is the first step, which is important, which is RDS, which is the slowest step in the reaction. The second step is the attacking of nucleophile, and third step the formation of alcohol, the formation of another product. Now if we consider further, if we see the characteristic of the reaction, rate is directly proportional to the concentration of RCl. Rate is independent of nucleophile, because first step, there is no involvement of nucleophile, is not involved. Nucleophile is not involved. So we know in first step nucleophile is not involved, and first step is RDS. So RCl is the independent rate, is independent the concentration of nucleophile. So it is of first order. So now if we see more stable carbocation, more will be the rate. So rate is directly proportional to the stability of carbocation. It can help us to identify the rate of the reaction when different types of reactant are given. Then we can find out the rate of reaction according to stability of carbocation. Now rearrangement is possible in the reaction. We have know there is a free carbocation is there. When free carbocation is there, we know rearrangement is possible. Now we talk about racemization can take place. Yes, racemization can take place because whenever free carbocation, the next nucleophile is attaching, it has two sides. It can form R and S equally chances there could be R and S, or we can say it is positive or negative. There is a very equal chance because carbocation is sp2 hybridized. Now it is free. So if we see it is sp2 hybridized, we consider it is a planar. Okay, so now if nucleophile is attacking from this side or nucleophile is attacking from this side, it can get different configuration. It may get R or it may get S, and it may get S. If it may get S, then it may get R. So it depends. Okay, it is equally proportional. It don't have any chances that it will be. If it is 50%, it will also be 50%. So reaction is in liquid phase. Yeah, reaction always in liquid phase. In gas phase, reaction is not possible. If we talk about gas phase, the reaction is not possible. If we talk about SN1 is stereoselective but not stereospecific. We know that it is not stereospecific because it is not specifying the stereo isomer of the product, because of the product obtained are same. It is equally negative and positive, or we can say RS equally, or we can say DL. They have equal configuration, equal amount. It is not specifying whether the reaction is R or S, whether the reaction is D or L, but it is it's still a stereoselective reaction. Now the reaction is stereoselective because a single reactant is deciding the formation of two different products which are equal in mixture, which are stereoisomer. Now we see formation of carbocation is RDS. So more stable the carbocation, more is the rate. So we know product will form in acidic medium. So the product we will getting by the result of the removal of H plus. So the product we will get, it will be in acidic medium. So if we see further points, solvation energy will be converted into activation energy in this reaction. So when we dissolve the alkyl halide, the energy release will convert into activation energy in this reaction. This is a point that whatever the solvation energy, that will convert into activation energy in its reaction. So it is self-activated reaction. Perfect racemization does not take place in SN1. Inversion product dominates in retention in SN1. So that is a little bit point to be memorized. Like perfect racemization is not there. If we call like 50% and 50%, so it is not there. It's slightly the inversion product is dominating over SN1. So if we see here, like if we talk about its transition state, so its transition state is delta positive and Cl delta negative. Now if we talk about, it is a little bit inverted product. Okay, so inversion is there. So we can say transition state undergoes SN2 partially. So like if we have an alkyl halide here and it is forming a product here which is R plus, okay, which is we are now, it is transition state. Now after transition state we are getting the carbocation. When we are getting the carbocation, it is forming 49 and 49. So 49 will be in case of retention and 49 will be inversion. So we know that a little bit where the two molecule gone in inversion, because two molecule all that have phase SN2 mechanism, but remaining 98 are facing SN1 mechanism. So we know that extra two molecule is going in case of inversion. So perfect racemization is not there. Inversion products dominate over retention in SN1.